voltage equals current times resistance. I haven't written on this thing in a while. I'm a little bit out of practice, but hopefully you're following okay. And power equals voltage times current. Okay, so that's P equals V times I. So what I want you to see here is that on this problem, I'm giving power and voltage. Okay, so when you see W, W stands for watts. Everybody has hopefully heard of watts when you have to pay your energy bill. So P equals V times I. So all of these elements here are in series. That means they're head to tail, and they all have the same current. So if power equals V times I, and I have 30 watts, then that means V1, the voltage across that first element, is 30 over I. The voltage across that second element is 40 over I. And the voltage across that third element, V3, is 50 over I. Welcome, everyone. Thanks for coming in and hanging with me a little. So glad to see you. So the sum of the voltages around the loop equals 0. That's called KVL. The sum of the voltages around a loop is equal to 0. So that means that 100 equals 30 over I plus 40 over I plus 50 over I. So now, how would I solve this for the current? I have one equation and one unknown. So the first thing you're going to do is you have a common denominator. So I can rewrite this as 100 equals, yep, welcome, come on in. Some days I'm going to do robotics and some days I'm going to do circuits. It kind of depends on the day. So I'm trying this for today and I'll try something else later. 30 plus 40 plus 50 is 120 over I. So that means that if I solve that for I equals 120 divided by 100. 120 divided by 100. I got to figure out how to get this stuff off of here. And I don't know how to do this. Yeah, this is kind of in the way. I equals 120 divided by 100. So I is equal to 1.2 amps. So the good news is now that I know I is equal to 1.2 amps, I am going to zoom out a little bit. So that means what you should see here is that since I is equal to 1.2 amps, I now can find the voltage. So that means the voltage for that 30 watt source is going to be 30 divided by 1.2. The voltage for that 40 watt source is going to be 40 divided by 1.2. And the voltage for that 50 watt source is going to be 50 divided by 1.2. Okay, let me zoom in on this a little bit so it's not so hard to see what's going on. All right, 50 divided by 1.2. So now I don't have my calculator with me, so I got to get an on-screen calculator. 30 divided by 1.2 is 25 volts. 25 volts. 30 divided by 1.2 is 25 volts. 40 divided by 1.2 is 33.33 volts. And 50 divided by 1.2. 50 divided by 1.2 is 41.67 volts. Okay, so now the last thing we got to do is we have to check our work. And so let's talk about how do we check our work. So we talked about that Kirchhoff's voltage law states that the sum of the voltages around the loop is equal to 0. So now that I've told you the voltage for each of those lamps, if I add all of those up, they got to add back up to my source. So if they add up to the source, then that means that it's correct. So that means that 100, this is Kirchhoff's voltage law, KVL, has to equal 25 plus 33.33 plus 41.67. So that's 42. 42 plus 33 is 75. So we do indeed have 100 equals 100.